Well, heidi ho, neighbor.
Hey, hey.
How goes it, everybody? So another glorious Thursday at the end of August. We're starting to get into that fake fall season right now. I'll give you a nice little touch of chill for a day, and then hey, guess what? It's 100 degrees again.
Yeah, I've been having a light jacket the last week, but I'm sure it's going to be either 2 degrees or 100 degrees in like 2 weeks.
Yep. Say roll the dice. We'll see how lucky you get this year.
Yeah, for sure.
So here we are again, another Threat Thursday live. Today we are talking state-based detections, everybody, and why they are awesome. Where this kind of comes along is we've seen it time and time again. We'll run purple team engagements, help other customers with them working on their detections, shoring up their security postures. And we always kind of hear the same phrase from most of the companies, and that's, oh, we've got a detection for that. We've got an alert for that. That's fine. Until we do something a little sneaky, or we just kind of change up the way we're doing things. And it turns out that their actual detection or alert happened to be just keyword searching for who am I, or looking for something like simply like that. And a little bit of obfuscation or just doing something in a different manner completely blows the detections away. So we figured we would talk to you guys a bit today about how we see detections, how we would rely more on state-based detections versus like keyword searching or looking for other common strings and things like that. So that's kind of where we're at, what we're going to talk through. Let's show them what we got, Tyler.
Yeah, for sure. So let me put we got here on the screen. Mine set up. So like Trey was saying, kind of the thought behind this is that there are multiple different ways for an adversary to perform an action on your endpoint, right? They could run it either in memory, they could do a BOF execution, it could be encoded PowerShell, all kinds of ways to kind of bypass like a simple keyword detection. So to kind of prove that and show kind of the benefit of state-based detections, we ran a bunch of commands in Scythe using the upshell module, which is unmanaged PowerShell. So it doesn't have the typical kind of logging that you would need to be able to like capture this command line activity. So you will have to rely on other means to find it. And we call that a state-based detection. So a state-based detection, contrary to a keyword detection, is when you focus on changes that are made to the endpoint that have to occur when an action happens, right? So an example of that is this first command that we have ran here. We just cleared the security event log, right? So we use just the clear event log commandlet. Security tells it which log to clear. And we ran it in upshell. So like I said, it's not going to be logged in a typical kind of way. And then kind of the proof is in the pudding. This is how the whole kind of webinar is going to go. I'll show you the commands and we'll switch over to Splunk and then show you. So on the left, we did just a keyword search on clear event log with some asterisks on either side. As you can see, this didn't return anything, right? We ran this command in upshell, just like we ran all of these commands that we're going to be talking about. So the logging is not in the security event log. You would need some additional tuning or things like that to be able to see it. But you could imagine if it was ran, if they changed this to an encoded PowerShell, or if they ran it through a BOF, which is a beacon object file that runs in memory or something like that. So however they did it, if you just looked for clear event log, like we're doing here on the left, you're not going to return any results. So instead of looking for keyword-based detections, you want to focus on those state-based detections, those things that have to happen. So even though they cleared the event log, once you do that, it creates its own event, right? It creates an event 1102, which is that the security log is cleared. So once they clear the event log, this log entry has to be created. You can clear it 100 times. You're just going to keep having this be the only log entry that's inside of your security event log. So that's one way. Oh, yeah, Trey.
Saying we've got a few other examples of this as well, moving all the way through the kill chain. For a threat to really cause some kind of impact or do something on an endpoint in your environment, they're going to have to make a change, right? They want to set persistence, means they're going to have to do something like create a user, change a registry key, do some kind of scheduled task. All of that adds a change. It does something on the endpoint. So you have the visibility, even though you may not have the logs of what they exactly did.
Yeah, for sure. Kind of leave you some breadcrumbs on there. And you brought up a good point that I was going to kind of tangentially hit on, in that to do impact commands, or to put an impact on the system, something has to change, as opposed to when you do like some reconnaissance or enumeration commands. Those might not necessarily change anything on the endpoint, because it just returns, like if you run who am I, it's just going to return that who am I information. It's not going to make any changes on the disk really, other than maybe the image of that being called. So all the detections that we're going to show here are really focused on ones that make a change to the endpoint, vice some of the more kind of simpler ones like the enumerations that don't make any changes. Yeah, so that's an example for the event log clearing. Next up, we have to make a new local user. We're going to make this demo user, give them a password and stuff, and then we're going to add that user to the administrators group. So again, oh, sorry, wrong tab. Again,
And this is something that should have had a physical actual change. There's a new user count. The group count of users has changed. There's new profiles, all kinds of stuff that happen at this point.
For sure. So just the easy way, I'll put both of them I don't know if I'll be able to put both of them on screen, might be a little too zoomed in. But we look for just new user, asterisks all around, right? So any usage of this commandlet should trigger. The same with the add local group member, and it doesn't return any events. But event code 4720, which is in your security log, which is a new user count has been created, that will log what user you have in place, right? This is also kind of points out another great benefit of using a seam, because if the adversary were to make a new user and then run this clear event log commandlet, then the only thing you would get in your logs is that the event log was cleared. But by having a seam and having all of your information being sent in essentially real time to your seam and logged elsewhere, you're still able to preserve all of these logs and kind of track down what the adversary is doing.
The nice thing here with this one, Tyler, is let's say that log is cleared. They clear it again after they do the user creation. There's still other ways for us to tell and the potential checks we could put in place, right? So if you create a user, that actual OU account for them will be off, especially if you try to do things like add them to a privileged groups, things like that. So having a simple check that round robins once a day takes a look. Hey, has the domain administrator admin count changed? Yes or no? If it has, okay, what's up? We didn't hire anybody new, so all of a sudden, why do we have a new DA? That's the other kind of routes you can take with this too.
Yeah, for sure. But say if you're ingesting your Active Directory logs, or just running like Active Directory query on an endpoint every day, you could just have it do like a stats count by users and then compare it every day. There's a neat chart in Splunk that will show you the change every day. I think it uses the diff command, and then we'll give you like an arrow up or down and give you the number of how many it increased or decreased. You also too, like you were saying, Trey, this is going to create a user profile once this user logs in. So you could also monitor for like new profile creations, inside of like C : users, and see if there's any new directories that were made in there as well. And then you saw, so we created that user and we added that user as a local administrator. So that, again, you can see by keyword searching, it doesn't come up with anything. But if you look in event code 4732, you can see that a new user was added to a security enabled local group, which should be an elevated group, right? You can see in here, so I tabled out the SID of the user that performed this action. So this is the SID of the administrator account. The name here just give you some more info that a member was added to a security enabled local group. It doesn't list the name out, but it does list the SID, the security ID, and you can see that it's different. That's 1,000, probably the first local admin that was made on this machine, and then 500, which is the domain admin account. And you can see they were added to the administrators group. So you would have to then look up this SID in some other log, and then join it to get the member account name. I think the only reason that the member account name didn't get added here, why it's the dash, is because that account doesn't have a profile or anything. So we just made it a few seconds ago before we added it to the group. So I think that might be why it wasn't logged correctly, but you could always take the SID and then look that user up on your domain controller. And then switch back to Scythe. I'm doing this in core stack, so I keep wanting to change the tab to this top one instead of inside of the window. So in here, we're just going to register a scheduled task This is going to be called Microsoft Xbox U. So inside of that, we're looking for a scheduled task creation. Again, just looking for the word scheduled task. The keyword scheduled task is not going to find what you're looking for. This one is a little bit more abstract maybe than some of the previous event logs we were looking in. So like, for example, event code 4732 is just when a member is added. There's not an event code for when a security group is, or excuse me, for when a scheduled task is made. So instead, what we're going to do is look for file creations inside of a few different tasks directories. So there's C Windows tasks, C Windows System 32 tasks, and a third place. I don't remember where the third one is, but there's 3 different task folders where a scheduled task could be written to. So while we don't have the command line visibility over what happened, we can see that a new scheduled task right here was made called Microsoft Xbox U. We had some other ones that were made as well, this under the Google Updater, this under sa.dat. This also brings up a good point in that your machines are still going to create things that might look anomalous, right? Or might look odd. They do all kinds of different stuff. So it creating this sa.dat, not sure what that is. This Google Updater is more than likely probably just the actual Google Updater that's running. So doing something here where like maybe you do a count every day of how many scheduled tasks you have created might return some values that require a little more investigation. But it's definitely a good starting point. And once you do it kind of more often, the more you'll recognize what tasks do belong there and which ones are new, right? You can even put some exclusions in if you see this sa.dat being written every day. And then you should also see that SVC host is the image that should be placing your scheduled task in this directory, right? And that's important because if you were to create a scheduled task on your machine, not on a victim machine, just on your machine, you create a scheduled task, and then like in Scythe, you put that in the virtual file system, you download it to the endpoint, you put it inside one of these tasks directories. It'll still register it as a task, but that image is not going to come from SVC host. It'll come from whatever your implant is called, or whatever whatever means you're utilizing to place that file there. So if you're not seeing it performed by SVC host, which controls the services and scheduled tasks and things like that, it should be the parent image of all those. If you see it not done by this image, then that's probably an issue that you need to look out for as well. And then over to next up, we do a service creation. So we just make the service, we call it evil service, and it runs evil.exe, right? Nothing super crazy. You see, if you just keyword search for evil, you'll be able to find all the bad guys. But if you keyword search for new service, again, like we've seen, it doesn't come up with anything. But over in event code 12 and 13, which are sysmon event codes, I should have said that for the file creation too. I'm sorry that I didn't. But the file creation and event code 12 and 13 are sysmon. That's what we have in our lab. But you should get a similar telemetry from whatever EDR you use. So in this, we're looking for 12, which is registry object added or deleted, and then 13, which is the registry value is set. So we see here that this, and it's looking for this to occur inside of this current control set services directory. So we want to look specifically in there to see if these are changed. You could also modify your query to just look at any registry changes that occur, but similar to like how we saw the scheduled tasks had 2 extra scheduled tasks in there. If you look just for registry changes, you're going to get a lot of results back, right? I mean, probably hundreds or thousands of results back, just because registries are constantly updated, really from like Edge and Chrome and things like that do updates kind of constantly and generate a lot of temp files. So you'll probably want to be more specific to the things that could affect you if you're looking at registry changes. But for service creation, it has to exist inside of here. So you could, again, do a count on how many exist, or you could have this just table out what the details are. So you can see that it's running evil.exe, and you can see that it's set to be, that this is start, and 2 is set for automatic. So this should automatically turn on once the system is turned on. And then next up, we get into placing a file inside of the startup directories. So here we just use the downloader module to download benign.exe. It's just a regular executable, it doesn't really do anything. But to download that to Windows Start Menu Programs Startup, we'll call this evil.exe. The overwrite just overwrites it in case there's one that's already there. So for this, similar to the scheduled task, we're just looking for a file creation in a certain spot. So we're looking for event code 11, which is file creation inside of the startup directory. The search actually goes for this whole piece, Microsoft Windows Start Menu Program Startup. I just didn't want to type up the whole thing up here in the line. But on that, you can see that our this is our scythe implant, just TT shell, thread Thursday shell that I ran all of these commands from. You can see that this placed a file in the startup directory, placed evil.exe in the startup directory. So just by monitoring that, this you should see very little changes for, especially if you go through some kind of change management board for any kind of like programs to be installed or things like that. You shouldn't see a lot of new programs put in your startup directory. So that's a good one to monitor just really by count to see. But this also shows like if we downloaded a file to that tasks directory I was talking about a few minutes ago, you would see that the image would be this TT shell instead of being SVC host, which should trigger you that something bad is happening, right? Or at least something odd, something anomalous.
What's pretty cool about this here too is so far we've seen steps that are covering a good portion of the kill chain. We saw like a little bit of recon, we saw different persistence measures, we saw ingress tool transfers, and now I think you're about to show them something with impact, right?
Yeah,
We're
should be
starting
able
to
to see some impact here. So the last one that we have was a little trickier. This query, this detection could definitely be a little more enriched. And I'll talk about that here in a minute. So for this, we are looking at some exfiltration staging. So right before they exfil something, more often than not, you'll see all of these files compressed into one zip file, so then they get uploaded all at once instead of having to upload 100 or 1,000 different files. Excuse me. So in that first, I just placed a bunch of random files inside of this directory. I put, I think, 25 of them in their 5 megabytes, I think. So I placed all the files in there, and then I compressed them all to a staged.zip file. So you look for just compress archive, like we've been saying, you're not going to be able to see it because we're running it in upshell, so it's logged a little differently. But so what we're doing instead is looking again for file creation, and we're looking for the file to end in .zip, .rar, .tar. You can add on different file extensions, but these 3 common ones, I think are going to give you a pretty good shot at finding them. And then if these files are written outside of program files x86, system32, or Windows system temp directories, and the reason why those are excluded is because those generate a ton of zip files on their own, and well, I don't like to say that any directory is a trusted directory. There's less of a risk of somebody placing a zip file in here because these are going to require some higher privileges. They're normally watched a little bit closer. And most of the time, like at least in the reporting that we read, when people stage archives, it's in temp, it's in public, it's in the documents, it's in the user profile somewhere, or it's in public or temp. Most often it's in public or temp. So in here, we could see that the user administrator, we could probably put the image in here too, and you see that the image is TT shell. That the administrator is creating a file called stage.zip that's inside of temp.
Super suspicious.
Super suspicious. The one way I was saying that this definitely needs to be tuned a little bit more, it's just not available in Sysmon. But if you were able to do this by file size, right? So a lot of programs, when they're doing updates or making temp files or kind of cached things or things like that, they will make archives, but they're very, very small, right? It's just like a rolling backup or a rolling archive of whatever that program is doing. Where if an adversary is trying to exfil a lot of data, they're probably going, or is trying to exfil some files, it's probably going to be a larger chunk of data. So ideally, you would be able to put some logic in here that looks at the file size of the zip file, and then have some kind of threshold for what is too large of a file that's suspicious. You should be able to get that information from your EDR. I think too that your EDR, or there's another log location that I'm drawing a blank on. But if you are ingesting that, you should be able to just join your EDR logs with your endpoint logs and then get the file size out of it, and then see what is kind of I would do a stats and eval, the kind of average size of the files you're looking at, and then maybe do, like, if it's 20% over your average size, you want to be alerted on it, right? Something like that. Also, ideally, if you're able to ingest MIME types, being able to look at MIME types is a lot better of a detection than kind of what we're doing, kind of keyword detections here on the zip, RAR, and tar. If you could look at the MIME type, then you know for sure that this file is a compressed archive or password protected archive or something like that. That'll give you more fidelity into that this is in fact an archived file instead of just the file name being different. Because you could evade this by just changing stage.zip to stage.txt. You could still exfil that out, and it would be fine. You could exfil out a stage.txt, change it to stage.zip on your endpoint, and then it's a zip file again. So just one, you could definitely tweak this one a little bit more, but with the logging that we have available, the security event log and sysmon logs, that's the best that we could do, right? So it's better to have something than to not have anything at all. But those were all of the detections that I was gonna talk about. I think I might be just at time, just over time.
Over.
And then there was one, I'm not going to go through the article, but when Trey and I did B-Sides Tampa a couple months ago, and when I was there, we were doing a hunting through the seam workshop, and this gentleman, his name was Curtis, I was talking about state-based detections, and he said that MITRE has a similar approach to it. They don't call it state-based detections, they call it like focusing on behavior. And things like that. But he showed me this article that I just linked that kind of talks about the same thing, just kind of reinforce the same concepts that we're talking about. And then this one line in particular, that the intrusion-based detection program incorporating behavioral detection is more resilient because it kind of looks past all of those signature-based detections like IP addresses, hashes, things like that. So that's not just from us, that's from MITRE. That's what they say. So just wanted to put a little more in there, that it's not us just kind of talking about whatever. It's nice to see that other places kind of have the same the same mindset. But that, Trey, over to you.
But yeah, so that was kind of the whole concept we had for today. It was cool to see some of these actually in action. I know they may not have been the most like sophisticated way to look at it, but it just shows really what's necessary when you're trying to pay attention to the state as opposed to keywords and signatures and things like that. Something has to change for them to have impact. So this is the best way, in our opinions, to go and find it and hunt it. With that, I think that wraps us up for today. For those of you watching, if you're in the Raleigh-Durham area, I'll be out there at B-Sides on the 12th. Outside of that, I think we have one more Threat Thursday right before that. I think the 11th.
Maybe. You throw me out. I don't know.
It's a future us.
But yeah, see you guys next month. Everybody have a good long weekend, and see you soon.
Yep. Till next time.
Bye, everybody.